Hello guys, welcome back to Math Zone African Motives. Still working on our mathematics N5 integration. So we shall be focusing on the applications of integration from our previous class that we had. We talked about the area. That was just the area that we have between a certain graph and the reference axis and the given limits that you be given for that particular function or curve or graph that you have. So in this case, we shall be focusing again on the same area, but the only difference that we shall see here is that this area now is bounded by two graphs or two curves. In this case, we shall be talking about the area that we are going to be having between the two curves. Remember, we referred about the area in the x-axis when you are given a single curve, in this case, whereby you are supposed to be focusing with the limits a and b, the representative strip with respect to x, and your area with respect to x being the integral of y with respect to x and even. So now you shall see that we shall have something of this nature, whereby now we've got two functions to be considered, one on top and the other one below. So that is the condition that we are now having. So it is just a same scenario of integration, just like the previous part. But how are we going to perform this so that we obtain our area? That's the question. All right, so let us say we have got area in the x-axis, just like the previous part. Remember, we considered two things: the area in the x-axis and the area in the y-axis. So given the area in the x-axis, we shall have our function, in this case, two functions that we shall consider. All right, so that is our y-axis there. Let us just say we've got a function of this nature, and which is y is equal to f of x, and also another function of this nature, which is also y is equal to f of x. So as you can see, we've got two functions that we are considering. So these two functions, they intersect at these 2 points. At the point of intersection is where these two meet. They meet at these 2 points here. So you shall consider your points of intersection of the graphs in this case to say we are intersecting at A and we are also intersecting at B. So the area is going to be taken in between these two functions, between A and B, whereby the points A and B, they represent what? The point of intersection. So A and B, these are the points of intersection. In this case, we are simply talking about the point of intersection where the two graphs meet in this case. All right, so given this, meaning to say the area, we can have our representative strip for the area that is bounded between these two, that is between the point of intersection of the two graphs. That is, we are referring to this area in between from this point, all this part here. This is the area that you're going to consider between A and B. So the concept is that we are no longer having a single function where we just find the integral of y with respect to x given the limits a and b. We shall find the difference between these two graphs, but it must be the graph on top. All right, this is the graph of y is equal to f of x. Also, this will be another graph, y is equal to f of x. Maybe we can just say y is equal to gx, because we are just talking about a function being in terms of x. So we've got two functions that we have, the one that is on top and the other one that is below. So we're going to consider the graph that is on top. We can just write this in terms of y1. The graph that is below, this one that is on the, we consider to say your graph as it goes up like this. This is the one on top, all right? Then this is the one that is below. So you're going to consider the graph on top as y1 and the graph below as y2 like this. All right, so given the graph on top of SY1 and the graph below SY2, it follows that the area is going to be given as the integral. We're going to have the difference of the graphs in this case. In this case, that is Y1 minus Y2. That is the graph on top minus the graph below in terms of X. Remember, Y is in terms of X. Y also here is in terms of X. So it's going to be Y1 minus Y2. All right, we're having the limits taken at A up to B. So A and B representing our limits in this case. So you just have to integrate and apply our limits. So like I said, A and B, these are the point of intersection that you're going to have. So in order for you to obtain the point of intersection, which is the X values at the point of intersection, you just have to solve your graphs simultaneously so that you obtain the x values at the point of what? Of your intersection. So that's how we're going to calculate your area. It's just a straightforward calculation. You just have to subtract the two functions, the one on top minus the one below. So this is the one on top, then this is the one on the bottom in this case. All right, so it's the top one minus this one on the bottom in this case. Okay, so it can be a same scenario that we can consider if we are having our area in the y-axis, in this case our area in the y-axis. So just make sure also you watch the first part that we talked about this application of area, so that you understand, because this is just a continuation that you're going to have. So in the y-axis, we are going to have our functions. Now, let us just have them in this format. Just going to have our sketch in this case. All right. So let's say we've got the one that is on top, and we also have another graph that is below. So this is the one on top. Then we have got another graph that is below like this. All right. So if you are to consider to say that now we've got the limits that are being taken in the y-axis. So meaning to say at the point of intersection of the two graphs, we shall consider our values to the y-axis. Let us just say this point, it corresponds to C, and this point here, it corresponds to D. Just like here, we've got A and B. Now let us just say I've got C and what? C and D. So this is what you're going to have in between the graphs, because we are representing our limits because they are in the y-axis. We must have a representative strip corresponding to the y-axis. In this case, we're going to have our representative strip in this case corresponding to the y-axis. That means we must have the integral with respect to y of the given function, but this is the one on top, as it is on the positive. This is the more positive side. As we consider this other side, we are considering to the negative side. All right, so we shall have our graph in terms of x is equal to, remember what I said, if you're talking about y there, it must be x is equal to f of y. So meaning to say this is going to be a function of x is equal to f of y. All right, so you can just write as x1 on top, then x2 as the one that is below. So x1 is equal to f of x. X2 is also equal to a function in terms of x. So with this, having the limits in the y-axis, we can obtain our area, which is simply the difference that we are going to have between the one that is on top, which is x1, minus the one that is below. So our area, all right, so this is the area with respect to x, and we're going to have our area in the y-axis, which is going to be the integral of, going to have the difference of x1 and x2, the one on top, which is x1 minus the one below x2 with respect to y in this case. So x is a function of y in this case. All right, so it's going to be with respect to y. Then the limits taken from C to D, whereby C is the lower limit and D being the upper limit in this case. All right, so you're going to have C being the lower limit and D being the upper limit, like that. All right, so that's how you're going to find your area. So C and D are the points of intersection, just like what we had on A and B. So in order for you to calculate that, you have to solve your equations simultaneously to find that those points of intersection are the ones that you're going to consider. But there are some of the most confusing questions which you might think that we are actually applying this concept, whereas we are not even applying this concept. I want you to see this function before we properly talk about this concept here of these areas. I want you to check this question. It might be as if we are using this concept. We are asked in this case to calculate the area bounded by. So we're going to calculate the area bounded by, in this case. All right, so we've got a curve that we are given, which is actually a circle, in this case, x squared plus y squared, which is equal to 16. And also we are given the line of y is equal to x plus 1. So we are given the line of y is equal to x plus 1. All right, so it would be like, okay, let's consider this so that we will see. And also we are given to be taken in between the line of x is equal to 0, the line of x is y is equal to 0, and it must be in the first quadrant, in the first quadrant, and it must be in the first quadrant. We are given because remember, a circle, it covers all of the quadrants, all of the 4 quadrants. But here they have mentioned that our area is supposed to be in the first quadrant. So here we are supposed to calculate the area. So that is calculate the area bounded by. All right, the area bounded by. If we are to consider here, we are seeing that we have got a circle. X squared plus y squared is equal to 16. That is a circle that we're having there. So if we are to work this, we can draw a circle, and also for the straight line. So if we are, okay, let us just see what you're going to have for a circle. Remember, for a circle, you just need the x-intercepts when y is equal to 0. It means we are going to have x squared is equal to 16. So the values of x will be the square root of 16, which is plus or minus 4. So it's going to be at plus or minus 4. Then for the y-intercept, it also on a condition that y, this one must be equal to 0. All right, for the y-intercept, x must be equal to 0 this time. So if x is equal to 0, it means y squared is going to be equal to 16, and y is going to be plus or minus 4, which is the square root of what? The square root of 16. So as you can see, we are having a circle that is going to pass the x-axis at -4 and +4, the y-axis at -4 and also at +4. So we are here, I'm just going to have a sketch. Let us just have a sketch of what was going to happen. In this case, it's not going to be as accurate as it is supposed to be, but I want you to have idea of what is happening here. All right, so this is something of this nature. We've got our x-axis and our y-axis in this case. So as you can see, it's a circle that you have. So you are going to have a circle passing through these points 4, and these are the same that we have from the origin. In this case, we're going to have the same distance. So you're going to have maybe something of this nature passing through the point to the y-axis at +4, down here at -4. The x-axis, we also have +4 and a -4 on the in this case. All right, so this is the equation of the circle that we have x squared plus y squared is equal to 16. We shall see, depending with the format of the equation, how we can write it at the end. But for the meantime, let us just have it this way. And we also have a straight line y is equal to x plus 1, where we can just have this direct, just like on our circle, we can just find the values of the x-intercept in this case. Remember, for the x-intercept, y must be equal to 0. So if y is equal to 0, it means that's a 0 there. So x will be equal to -1. If we transpose 1 to that side, x is going to be equal to -1. Then for the y-intercept, we know that x must be equal to 0. So if x is equal to 0, that means the value of y is going to be equal to 1. 0 plus 1, that's a 1. So y is going to be equal to 1. So it means the points that we're going to focus on in this case are the value -1 for x and a +1 for y. So let's just say we've got that's -1, -2, and -3. And we've got +1, +2, +3, something like that. It's only that here I'm not using a proper scale, but we can have something of this nature there. So if we are to check properly, the -1 in the x-axis can be somewhere here. Then the +1 in the y can be somewhere here. Then we can join our points. And also, as it goes out, we can see that at point, maybe at point 4, if x is equal to 4, which is this value here, at x is equal to 4, we are going to have 4 plus 1, which is 5. It's actually out of the region that we are seeing of the circle in this case. So you're going to have something. So it's not actually going to intersect at 4, because 4 is actually out of the interval. If we check here at 4, it's actually away or out of the interval in this case. But this or these two, they are going to intersect at this point here and also at this point here. These two, they are going to intersect there. So how are we going to determine the points of intersection? Because we need to know this point, because here, if we are to consider in the first quadrant, this is the first quadrant that we have, all right? This is our first quadrant. So I want us to properly see what is happening, because here we do not want to confuse with this information. Like I said, we do not have exactly what this information that I listed here is about. But I want you to see the difference that we have, so that when we apply this area bounded by the two curves, we properly see this area that we are talking about here is not bounded. Let us check how the question is given. They are saying we must calculate the area bounded by this circle, which is, this is what we have on the circle, like this, all right? Then the line of y is equal to x plus 1, which is this one, all right? So if we are to consider properly the area that we're going to have, if we have these lines, x is equal to 0, which is x is equal to 0 is the y-axis, that is our line, x is equal to 0, y is equal to 0 is the x-axis. So you need the area bounded, but also they said in the first quadrant. So if we consider the area that is going to be left, that will be covered by the line and the circle, it is going to be here. X is equal to 0. Going to this point, it's still covered in the x-axis, it's still covered by the circle. Up to this point, then we consider a straight line up to this point. This is the region that we are supposed to have at the end, that they are referring to the information that we are given. So if we check here, this area is not, because this is the area that we are talking about. Let me just indicate so that you can properly see. This is the area that we are talking about. So this area is not a condition whereby there is a curve and another curve in between. All right, how so? Because if we check what is happening from this point, from 0 here, this is our starting point where x is equal to 0 here, up to 4. If we consider from 0 here, going up to this point, you will see that the circle is not involved, because we are not talking about the area that is bounded here. If the area was bounded, if this part was involved, but this one is not involved, this part. This part is not involved because it must be bounded between x is equal to 0, y is equal to 0. So here we just have y is equal, we do not have x is equal to 0, so we can't take this region. But here we've got y is equal to 0, x is equal to 0 is there, the curve, or which is the circle, is there, and also the line is there. So this is the region that we can take in between. So that's why I'm saying this region cannot qualify. So if we take note, the circle is not involved from this point up to the point of intersection here, up to this point here. The circle is not involved. We do not have a circle here. It's just a straight line that we are considering up to this point. Then, okay, let us move. I want you to properly see what I'm trying to say. From this point that we see, from the 0 point here up to this point, it's only the line that is affecting this area. Yes, the circle, you can see that there's a circle here on top, but this piece of a circle, this one, it's not affecting this area. The area is covered by the what? By the straight line. So as we are to consider our area, we are going to consider the straight line from 0 to the point of intersection. So in this case, let us just have it in short. We are going to see later on, because we want to find this area. And as you can see, the representative strip here is for x, because you can see our limits are in the x-axis. So we're going to have our representative strip. Okay, let me explain this. So I said our area, the first part, let's say we're going to consider two areas from 0 to the point of intersection. So from 0 to the point of intersection, we shall calculate that to the point of intersection. Our area in this case is going to be affected, or is going to be taken from the line. The circle is not involved. The circle is out of this region. So we are going to consider what is building up this area. What is building up this area? It's a straight line, this one. So we are going to consider or use a straight line. So there we are going to use a straight line. All right, so that's why I'm saying this question is actually out of the scope of what we are talking about. Area between two curves. It's not between two curves, like there are two curves, or there are two graphs, yes, but this one, it's not affected. From 0 to the point of intersection, we do not have. The same thing, as you can see, once you reach this point here, the line has played its role. It's now out of the shape. It's now out of the region. It's no longer within the region. It's not bounded. There is an open space that we see. So the line is no longer used. So the moment we reach the point of intersection here, meaning to say now we are left with a circle, the part that is covering the area, this piece here, the part that is covering here, this one, it's not of a line. The line ended at this point, and it's no longer into the curve. It's out of the curve. So the part that is now affecting our area is the circle, not the straight line. So meaning to say, from the point of intersection in this case, all right, from the point of intersection, from the point of intersection up to 4, which is the end part of our circle or the region that we're talking about, it is ending at 4, it is bounded up to 4. So meaning to say up to 4 there, the only part that is affecting our area in this case, all right, our area, which is A, okay, we can just name this as area 1, then this will be our area 2. So area 2, which is this piece here, we're going to have our area 2, this is our area 1. So this area 2 is going to be affected by the circle. It's only the circle that is there. The straight line is out of the region. So there you are going to use the circle in this case for calculation of what? Of area. The part that you're supposed to consider there, it's a circle. These two, they are not covered like this to say we want an area here where this part is involved and also this curve is involved. So the part of y1 minus y2, now we are not even using it. They are separate curves that we are talking about here. The region that we are considering up to the point of intersection, the circle is not involved. From the point of intersection up to 4, the straight line is no longer involved. We are just left with the curve, which is the circle. So that's some of questions which might be a confusing type of a question, especially under exam or on your revision part. So you're supposed to know the difference between this. All right, so we're back to our area. Now we understand what is happening, and we're talking about the area being taken with respect to the x. So meaning to say we must have our formulas or whatever area that we are, whatever formula that we are given, equation of the curve that you're given, it must be of y is equal to what? F of x. We are supposed to have our integral with respect to x. So for a straight line is fine, it's already y is equal to f of x, but for a circle, we are supposed to make y to be the subject. So we have got, we are to make this to be the subject. It means that will be y squared is equal to transpose x squared to the other side of the equation. It will be a negative, so that will be 16 minus x squared. So determine the square root. That will be y is equal to the square root of 16 minus x squared. So this is the presentation of the equation of a circle in the form of y is equal to what? F of x, where this is our f of x. So that means we can determine our area. So the area this time is just going to be a combination of these two. There's no subtraction there, just like what we were saying here, whereby the area is bounded by two curves. We're going to have y1 minus y2. No, this part is not bounded. It's totally different. A certain region is used, another one is not there. On the certain part, the region is there, but the other one is not involved. Another part is there, another one is not involved. So meaning to say, we cannot use that. So in our calculation, we are supposed to use, yes, the formula for area from our integral. But like I said, we need the point of intersection here because we're gonna, as we said, from 0 to the point of intersection, from the point of intersection to 4. So what is that point of intersection in this case? So to find the point of intersection, we can simply equate the two. Remember, the point of intersection, I said you find it by solving the two equations. So let us just solve our equations here. We are given x squared plus y squared is equal to 16. So you can just have this as our equation 1 and this as our equation 2. So from equation 2, as you can see already, y is the subject. So you can substitute y is equal to x plus 1 in place of y in equation 1. So this is going to be given as x squared plus y squared, of which y is equal to x plus 1. So it's going to be x plus 1 squared, which is equal to 16. So there we just need the x values. We do not need the point of intersection like the value of y, but unless if the question is asking you for point of intersection, there we just need the values of x at the point of intersection. So you can solve this x squared, expand your brackets. That will be x squared plus 2x plus 1 minus 16 is equal to 0. Remember, guys, your identity is from your N4. expansion of brackets, or you can just open two brackets, x plus 1, x plus 1. You expand your brackets, you're going to have the same answer. So you're going to add this part, that will be 2x squared plus 2x, 1 minus 16, which is going to be negative 15 in this case. That will be equal to 0. So I've got a quadratic equation to be solved in this case. So we can use our quadratic formula. I don't think we've got factors there, so we can just use our quadratic formula where x is equal to minus b plus or minus the square root of b squared minus 4ac everything over 2a. So that's we've got the value of a, b, and c. So that's our x is going to be negative b, which is negative 2, plus or minus the square root of b squared. That will be 2 squared minus 4 times a, which is 2 in this case, times c. That will be negative 15. All right, so the whole part is divided by 2a in this case. So this is going to be over 2 times a, which is 2 times 2. So that's we're going to have two possible values of x if we simplify properly. The first value of x there at the point of intersection is going to be at positive, which is 2,284. We simplify properly, 2,284. Then the other value of x is going to be at negative 3,284. But as we can see, we are told that we are supposed to use the area that is in the first quadrant. So that means we are only considering the x being positive this side of the horizontal axis, and the other side it will be a negative. So you can't consider the x to be a negative. So our x cannot be this value a negative, but it can be a positive, which is 2,284. So the value of x that we are simply talking about, say the point of intersection, this and that, it's at 2,84. So this point here is at, just gonna write it here, 2,284, but you're supposed to write it here, 2,284. That's the value of x at the point of intersection. All right, now let us calculate our area. As we said, our area is going to be the combination of the two areas from 0 to 2,284, which is the point of intersection, then from 2,284 to 4 in this case. So that's the integral of, all right, so let us have our area. We're going to have this as, remember we said from 0 to the point of intersection, which is from 0 to 2,284, we are going to use a straight line. So our area is going to be the integral of what we have on a straight line, and the straight line is the integral of x plus 1. So we're going to consider the straight line only, that is x plus 1. With respect to x in this case, and the limits is from 0 to 2,84, from 0 to the point of intersection. That's the lower limit is 0, upper limit 2,284 in this case. All right. Then as we move from this point of intersection, as I said, the straight line is no longer there, it's out of the region. We are just left with the circle affecting the piece of area, that is the part of the area that we are supposed to calculate. So we're going to use the circle this time. So meaning to say for the circle, we are going to use y is equal to this as the subject. So we're going to add that because it's a combination. It's not between the two curves where you subtract. Here you're going to combine these two areas. So it's going to be the integral of y, which is the square root of 16 minus x squared, like this, with respect to x. So that is going to be our area taken from the point of intersection from 2,284 up to 4, which is the end point here at 4. So that means the limits is going to be 2,284, which is the lower limit, 2,284 to the upper limit, which is a 4 in this case. All right, so that is going to give us the total area to be calculated. All right, so let us simplify from the first part here. We are going to have the total area from this part and the second part combined together. So that means the total area is going to be given as the integral of x, that's going to add 1, which is going to be x squared over 2, plus the integral of 1, which is x, all right, with respect to x. Then the limits at 2,284 and the lower limit at 0 in this case, all right, plus we move on to the integral of 16 minus x squared with respect to x. All right, so this part here, we are going back. I want you to check back from your formula sheet. There's this integral that we have here. The integrals of f of x, here, the integral of f of x with respect to x. We have got this scenario that we have on this formula. The integral of this part here, the integral of the square root of a squared minus x squared. If we integrate this with respect to x, because we are given here the integral of f of x, and this is our f of x. So if we integrate this, this is what you're going to have at the end. So that is the best formula that you're going to consider. So I'm going to explain this formula there because we are given the square root. And this part, we are going to have it a lot in our N6. We're going to see these integrals a lot. So we saw that the integral of, I'm going to just write it here, then I'll erase. We saw that it is given as the integral of the square root. It's going to be, it was given as the square root of a squared minus x squared, like this, with respect to x. So from our formula, it was given as a squared over 2. Then we have got arcsine of x over a, like this, plus x over 2. The square root of a squared minus x squared plus c. Okay, I'm gonna explain this formula. What does it mean? If you are to consider here, we have got a term, a single term, which is a constant in this case. Then we've got an algebraic term, which is the one of x squared. So is it possible for us to write this 16 as a number to the exponent of 2? So it's possible this 16 here can be written as 4 to the exponent of 2. So it means we have got the square root in this case of 4 to the exponent of 2 minus x squared. So if we can be able to write our number in terms of a squared, we can use this formula where a is, in this case, is representing 4. That is our a. So wherever we see there, where there is a in this case, wherever we are seeing a, we are going to be writing what? We are going to be writing 4. And the x that we are seeing is the number that we have here, x squared. So we are going to focus with a and x. These two numbers being raised to the exponent of 2. So the solution that we are supposed to have in this case is supposed to be a squared over 2, of which a squared over 2 means 4 squared over 2. Our a is 4, so it's going to be 4 squared over 2, and 4 squared over 2, guys, is simply 16 over 2, which is 8. So that was going to give us 8. Then we have got arcsine of x over a. So our x in this case, as it is, then our a, so it's x over 4 in this case. So it's going to be arcsine of x over 4 in this case, plus x over 2. So as you can see, we're just taking our x as it is. So it's going to be x over 2. This is, there's nothing that you're going to do there. Then we have got the square root of a squared minus x squared. A squared minus x squared is the original expression that we had, meaning to say we are back to 4 squared minus x squared. But 4 squared is 16, so we just back to this part as it is, which is 16 minus x squared, like that. All right, plus the constant of integration. Like I said, if you are given the limits, there is no need for us to have what? This constant of integration. So that is how you apply this, all right, with the limits that you are given 2,284 up to 4 in this case, like that. So from there, it was just a matter of substitution that you're going to make. Just because of our time there, we're just going to substitute upper limit. In place of x, you substitute your upper limit minus the lower limit in this case, which is the same thing. So let us just see on our calculator, but this one we can just substitute. So let us check the first part. If we are to consider this, the upper limit is 2,284. So you're going to substitute 2,284 in place of x. So that is x squared. So it's going to be 2,284 squared over 2 plus x, which is 2,2. So you're going to add 2,284, like that. All right. So this is going to give us 4,8. All right, that's 4,89, something like that, right? So that's what you're going to have from this one. All right, we can just even subtract everything. Okay, that's if we substitute a 0 there, that would be a 0, this one. If we substitute here to be a 0 here, we also substitute a 0 because we've got upper limit minus lower limit. As you can see, this one is just going to give us a what? A 0. So meaning to say there's no effect. We're just going to have this, which is 4,8, 4,892, right? So you're going to have 4,892 in this case, which is from the first part, but we are supposed to add now the area from the other part, this one. So you're just going to have again, but now you're going to have the upper limit minus the lower limit in this case. All right, let us just have it aside here. So you're going to have the lower limit minus, the upper limit minus the lower limit in this case. So you're just going to maybe have a bracket like this, which is 8. And also, if you just have this part of arc sine, it means your calculator must be in radians. So you're going to use your calculator in radians. So change your calculator to radians in this case, which is on the 4 there, so that this must be R there. So that's shift sine, which is arc sine in this case. All right, 4/4, that's a 1, guys. Okay, you can just write, but that's 4/4, which is a 1 there. Plus also 4/2, which is 2, but you can just write 4/2. The square root of 16 squared, that's 16, minus x squared, which is 4 squared, which 4 squared is 16. So that will be a 0 there on this part. All right, anyways, that's the upper limit, which is at 4. Then we're going to substitute. When we subtract, we're going to substitute the lower limit at 2,284. So that will be 8 arc sine, which is shift sine in this case. So that's x, which is 2,284 over 4 in this case. All right, so that's over 4. All right, then this is plus x over 2, so it's going to be plus x, which is 2,284 over 2 in this case. All right, like this. Then we've got the square root of 16 minus x squared. So it's 16 minus our x, which is 2,284, like this. That's 2,284. All right, that's 84 squared. So you're going to square this part. All right, then we close everything. That is the bracket of everything. So that's it. We are going to obtain something like this part, which is 3,9. That would be 3,954. 3,954. All right, we've got 3,954 square units. All right, so we have to combine now these two areas that we obtained. The first one, which was 4,892. All right, plus the second one, which is a 3,9. All right, that's 954. 954 like this, 3,954 like this. So that is going to give us 8,846. So we've got 8,846. So that will be 8,846 square units in this case, which is unit squared. So like I said, is the area which is measured in square units, or you can just write as square units like that. So that is how we could have calculated this area. It's not bounded between the two graphs as we introduced there. It's not bounded between the two graphs. So the question is, what if it is bounded? Let us have a consideration when it is bounded so that we can properly apply the concept that we are having here, because we talked about having our area in the quadrants that is in between, bounded between the two graphs or so forth. All right, so let us check a question that is directly applying to this information that we had there. So just gonna have something here. All right, let me just erase this part and just have a question. So there we had a condition which was actually out of what we need, like as we are considering the area between the two curves, like we are talking about two graphs in this case, but it was a combination of two graphs, yes, but each separated from each other. It was not a condition where one is affecting another. Another one is on its own. The only thing that we got from those two graphs was the point of intersection. That was the only common part that we had from our graphs, or from those graphs that we were given. All right, let us consider these two graphs that we have. If we are given the area, calculate the area bounded by the graph. Let's say we've got the graph of y is equal to 5x minus x squared in this case, and the graph of y is equal to x squared minus 2x plus 1. So in most cases, you won't be given the limits, like where are you going to take your values to and from, because they know that you'll be given the point of intersection as your region that you're going to consider. So in this case, we've got two functions that we consider. In this case, we can just have to find our point of intersection, sketch your graphs from our Maths N4. Remember, if we've got a negative here on the quadratic function, it means we are going to have our curve going this way. If it is a positive there, we're going to have a smiley shape, which is going this way. All right. But we need the point of intersection of the two graphs because another one is going to intersect with another one at the end. So the point of intersection is, you can see, it's y, which is equal to this. And also here they're saying the same y that you're talking about is equal to this. So these two, they must be equal because here it's y and this one is also y. These two, they are equal. So it also means this part here and this part, they are also equal. So you can solve that using that concept straightforward. So that'll be 5x minus x squared is equal to x squared minus 2x plus 1. So we can solve for x. If we are to check, we can just take our values to one side of the equation and see what's going to happen. That's 0 is equal to, you're going to have x squared minus x squared. This side will be positive x squared minus 2x. Then 5x to this side will be negative 5x plus 1. That's 0 is equal to x squared plus x squared, which is 2x squared minus 7x plus 1. So this part, or if we are simply saying A is equal to B, it simply means B must be equal to A. So if B is equal to A, then what it simply means is that we can also write this as 2x squared minus 7x plus 1 equal to 0. What is the major part that we are following is the quadratic equation format that you're supposed to have. Ax squared plus bx plus c must be equal to 0. So you must have one of the sides equal to 0. So that we can use our quadratic formula. As you can see there, we do not have factors 2 and 1 and negative 7. There are no factors. So factorization there is limited. So we are back to the quadratic formula. Again, the application of the quadratic formula so that we can have our x values in this case. So if we are to use our quadratic formula, remember x is equivalent to negative b plus or minus the square root of b squared minus 4ac over 2a. So you can just substitute our values in this case. So we can calculate for x. That means from this part, we've got our a, our b, and our c. So our b, that's a negative 7. So on our substitution is going to be x is equivalent to negative b. So a negative and a negative there will be a positive. So that will be positive 7 plus or minus the square root of b squared, which is negative 7 squared minus 4 times a, which is 2, times c, which is a positive 1 in this case. Everything over 2a, which is 2 times 2. So that's it. So if we are to simplify, you can just have to simplify the part that is under the square root, this part under the square root, then you determine your values in this case, or you can just determine everything at once. I'm just gonna determine everything at once. You're gonna have two values of x equal to 3,3, 5, 1 in this case, or another value of x which will be equal to that will be 0,149 in this case. So these are the possible values of x. Just gonna have x1 and x2. If you want to find the point of intersection whereby we need the values of y also, you substitute these values into the original equation. But here, we just want these x values. Since we are to calculate area, we just need the values of x at the point of intersection. That is the value of what? The value of a and b. All right. So like I said, if you're given two functions, our area is going to be like this. All right. So let us check what is going to happen in between these two functions. The graph of y is equal to 5x minus x squared, and the graph of x squared minus 2x plus 1. So remember, if we are to sketch these graphs, we're going to see that, all right, they will intersect actually because we've got the point of intersection. Let us start with the graph of y is equal to we are given 5x minus x squared. So we've got 5x minus x squared in this case, all right? So this graph is same as we can just rewrite as minus x squared plus 5x like this. So we can have it in this way. And as you can see, we've got a negative value for x. In this case, we've got a negative value for x of x squared in this case. So it is going to be in this case, right? A set one. And if it is a positive, it's going to be having a smiley one like this. So if we are to consider also maybe the x values at the point of intersection, we're gonna the x values for the y-axis in this case, when you are talking about the values in the x-axis, that is y is equal to 0, you're going to have minus x, or just x in this case, into minus x plus 5, which is equal to 0 in this case. So x will be equal to 0, or x will be equal to positive 5. That will be where this graph is going to pass through the x-axis. And when x is equal to 0 for the y-axis, you're going to see y is equal to 0. So meaning to say, we can have something of this nature, because in the y-axis, for the y-intercept, x must be equal to 0, and it passes through the y-intercept. That is where its y-intercept is supposed to be. All right, and it's supposed to be what? It's supposed to be a said one like this, something of that nature. So meaning to say, you shall have our graph maybe ranging from this part going up, and it's gonna go down at what? At 5, because we have got this as the y-intercept, and also as the point of what? Of the x-intercept, which is we've got two solutions, 0 and 5. But this 0 is also the y-intercept, so it passes through here, and also it passes at 5. Okay, so this is the graph that we're gonna expect to have for y is equal to, all right, that's not y is equal to, but it's all right, y is equal to minus x squared. All right, it's fine. Y is equal to minus x squared plus 5x. All right, then we've got another graph which was of y is equal to it was x squared minus 2x. All right, y is equal to x squared minus 2x plus 1. Are we going to have the x-intercept in this case? We're just going to check if we've got the x-intercepts, and also how we're going to be just like the previous part. All right, so let us just check our x-intercept in this case. If we have got the value of y being equal to 0, it means we're going to have x squared minus 2x plus 1 is equal to 0. Then can this be factorized? That's a 1 there. Then we've got factors of 1, which will give us a -2. That will be -1 and -1. So we've got -1 and -1. -1 by -1 is +1. Then -1 plus -1, it's -2. So that will be at -1, -1. So x is going to be equal to 1, or x is equal to 1. So it's just at the same point. So meaning to say the point, or the x there that we see is it represents a solution and also a turning point. All right, then we need the y-intercept. The y-intercept is only a condition where x is equal to 0, and x is equal to 0 is going to be 0, 1. So like I was saying, that point, it represents that it's an x-intercept and also a turning point. And also, because of having the x squared being a positive, our graph is going to be a smiley one like this. So we're just going to have our turning point, it's at 0, 1, maybe 0, 1. 0, 1 is somewhere here. That's 0, 1. This is the y-intercept, right? This is the y-intercept, but the x-intercept is the turning point, not this one. This is the y-intercept, but at a point where x is equal to 1, maybe somewhere here, that's where we have 1, 0, because it will be the y-intercept. Remember, these are the x-intercepts where y is equal to 0. So it will be maybe somewhere here. That's 1, 2, 3, 4, and so on. So at this point, it's a solution, yes, but that point is also a turning point. If that point is repeating like this, it's a turning point. So our graph is going to be taken from its y-intercept at maybe 0, 1 there. That's the y-intercept at 0, 1. So it's going to be taken from the y-intercept to the turning point at this point, which is also the solution. So what happens? It bounces at the turning point there. This one, it goes on, because the turning point, the solution that we have here, it's also a turning point. So the curve bounces at this point. It is not going to pass like this. it is going to bounce because at 1, it's a turning point. It's also a solution. So it is just going to bounce like this, all right? Then it goes up. So that is how our graph was going to be like. So just have to consider, guys, the sketching of graph from our Mathematics N4, Mathematics N3 revisions, so that it helps us a lot as we are to sketch these graphs. All right, so that was the graph of y is equal to x squared minus 2x plus 1. So as you can consider, we said they are intersecting, yes, intersecting at this point. The value of x there, we now have to compare between these two. This is 0,149. So this is the best point to be 0,149. And that is 3,3, which is somewhere here. So it's going to be the best point to consider as our 3,3. So it's going to be 3,3, something like that. All right, let me just remove this part. All right, sorry, let me just put it this way. So you're going to have this point as 3,351, which is this part. All right, so as you can see, our limits that we have, or the values of x that we have limiting our function or our area, are in the x-axis. So the best that you can have is to have our representative strip in the x-axis, and the area that you can see it's bounded between our graphs. We can see it's taken from the point of intersection up to the point of intersection here, just like exactly what we had explained before. So this can actually help us now in the application of what we have explained on this part, to say area can be calculated between the two given graphs like this, whereby we're given A and B as the point of intersection, and that A and B is going to be used on your area, which is the area with respect to x is going to be y1 minus y2, which is the top minus the bottom. So that is the condition that you're going to apply there in your calculation of area, since you now have your curves or the graphs that you're given, and also the point of the values of x at the point of intersection. We do not want the values of y, we need the values of x there. So that's it, gonna have our representative strip with respect to x. So that means our area in this case with the respect to x is going to be the difference between y1 and y2 with respect to x, taking our limits from a to b, whereby y1 is the graph that is on top, the top one minus the bottom one. So this is y1, which is the graph on top. Y1 is this graph of minus x plus 5x, and y2 is the one below, which is the graph of y is equal to x squared. So you're going to subtract this now. So you have to subtract. So the area is going to be, so do not confuse with the first question that we did. I said that one is actually out of our context. It is just for us to know how questions can be given confusing to what we are supposed to be having. So now we can subtract these two. Y1, that is minus x squared plus 5x in this case, minus y2. Y2 is the one that is below, which is the graph of x squared minus 2x plus 1, like this. So that is what you're going to have. We have to subtract everything. We integrate this with respect to x, and our limits taken now between the point of intersection. We are using the point of intersection there, which is the value of x. The lower limit is 0,149, and the upper limit, which is at 3,351. You do not just take any value, you use the point of intersection now as your limit. So as you can see, guys, it's just back to your simplification, expanding of your brackets, simplifying your integrals in this case. So you're gonna have this as the integral of, we're gonna have the limits first. All right, let us just have our limits expand. This, what are you going to have? We're gonna have negative x squared plus 5x. If you expand this by negative here, it will be minus x squared. By negative here, it's going to be a positive 2x. Negative and positive, that will be -1. Collect your like terms, -1, -1, it will be negative 2x squared. 5x plus 2x, that will be 7x in this case. Then we've got a -1. So meaning to say the whole of this part that we are seeing, it is going to give us negative 2x squared plus 7x minus 1 with respect to x. So this is the part that you are going to integrate. After that, you apply your limits that you have the area in this case. So let us integrate. Okay, going to add 1 here, which is negative 2x to the exponent of 3 over 3 plus, if we add 1, that will be 7x squared over 2 minus x there. 1 is just same as minus x, all right? Then we consider our limits, the upper limit 3,351, 0,149, like that, all right? So that's it. We have to substitute upper limit minus the lower limit, just like the previous part that we had. This will give us our area in this case if we substitute the upper limit and lower limit concept. So our area with respect to x is going to be negative 2 into, we substitute, that will be 3,351 cubed over 3 plus 7 into x, which is going to be 3,351 squared over 2 minus x, which is 3,351. That's for the upper limit in this case. Then we subtract for the lower limit, which is at 0,149. So it's going to be negative 2 into x, which is 0,149 cubed over 3 in this case, all right, plus 7 into our x, which is 0,149, but being squared, all right, everything over 2. So you're going to have everything over 2 minus x, and the x there is 0,149. That's 0,149, like this. All right, so that's what you're going to have on your simplification. You have the area that is going to correspond with respect to x. So if you are to simplify this properly on your calculator, guys, the first part here that you're gonna have was going to be something like 10,865 minus, this was going to give us a negative value there. We're going to obtain a negative on this part. So we're gonna have our answer having a negative on the formula. Then from this one, this part here that I'm talking about, it gives us also a negative, which is 0,074, like this, all right? So as you can see, negative, negative, it is going to be a positive, and that is going to give us 10,939 square units in this case. All right, so this is going to be our area in square units. All right, so these are the typical questions that you might be given as long you are dealing with the area that is taken between curves or between the given graphs, if you've got two graphs that you have. So like I said on our introduction, or on this part, you can also have your area that is taken or to be limited across the y-axis in this case, whereby you're going to use the formula for x1 minus x2 with respect to the y, just like what we had on the x-axis. So I want you to try to work on more questions on this part, and also to join the membership so that we discuss about these typical questions of this nature, so that you revise this part as you are working towards your exams. So joining membership is actually very, very important, guys. It helps us to have more videos to reach you guys before you write your exams. So just click any one of the videos that are there on the membership so that you can follow the steps on how to join the membership, so that you won't be left out, as we shall be revising or working with questions of this nature and other questions to come, which will be a token to our members. So make sure that you join so that you won't be left out in any of the revisions that we shall be having as a preparation for our exams that are ahead of time.